So for the next section, or 10.5, it's a bunch of reactions with acids and bases. We are only going to talk about one type of reaction, and that is a neutralization reaction. So if you are a person who likes to read the book, follow along, please, please, please ignore all of the other sections. Okay, only look at the neutralization reaction section. Okay, and also we are not going to be doing any calculations with this. Okay, so we're looking at the chemical equation only. And no calculations. So your book goes through some calculations with this using the mole road. We're just going to look at the balancing the, or writing out the chemical equation. Okay. So let's look at what this neutralization reaction is. Okay, what it means to have this neutralization happen. What's going to happen is all of the acidic protons, okay, so all of the hydrogens listed out in front of your formula are going to form, or they're going to contribute to water. Okay, obviously we have to get oxygen. Okay, and we'll talk about where that comes from. But all of these acidic protons are going to contribute to preparing water. Okay, and it's neutralization because water, if that's our product, is neutral. So how we do this, how neutralization occurs, okay, it's just a specific type of chemical reaction. This doesn't happen all the time, okay, but we're going to take an acid. We are going to add that to a base. And like I said, all of the acidic protons are going to contribute to water. We're going to get the oxygens, and actually oxygen and a hydrogen from the base, and that's going to form water. And then what's left over is going to be a salt. And another word, again, for salt is an ionic compound. So from the acid, that's where we're going to get our protons, our H's. From our base, that's where we're going to get OH minus. Okay, and that's what's going to produce our water. Okay. So, kind of our steps to writing a balanced chemical equation for neutralization. Okay, I differ from the book on this. Okay, that's not to say the book is wrong. I just find the book's method a little more confusing. Okay, so I would encourage you to maybe try the way that I'm laying out, and if that doesn't work for you, if you've tried a bunch of examples and it just doesn't work, go ahead and try the method in the book. Okay, just do not combine the two. Okay, don't combine the book's method and my method together. Okay, they need to be considered separately. So let's first write out the steps for balancing a chemical equation. Okay, for the neutralization. Step 1, okay, is you are going to write the formula of the salt. How we are going to do that, okay, is you are going to get the cation, the positively charged component, the first component, from the base, and you are going to get the anion, the negative charge, from the acid. Now, when you do this, okay, when you write out this formula, you have to remember the rules from Chapter 5. And that's, I told you, Chapter 5 was never going to go away. We're always going to be building on it. Okay, Chapter 5 was where we talked about the naming and the formulas. Okay, so we have to combine these. We have to first determine what their charges are, and then we have to do that cross-charge method to figure out what the formula is. And then basically what we're left over with then contributes to our water. Okay. Basically what neutralization reactions are these are your double displacement reactions. And that's all it is. It's just a special version of that. All right, step 2, once you've determined your salt, is you want to write out your chemical equation. In other words, you're going to write out your reactants, put your reaction arrow, and put your products. So again, basically we're just having your acid plus your base, and you're going to form your water and your salt. Step 3 is you're going to balance the chemical equation. And here really is the specific area that I differ from the book, and that I would suggest you assign a 1 to the salt. Then balance the acid. Then balance the base. So you're going to balance the acid according to the anion and the salt, and the base is going to be balanced via the cation from the salt. Then you want to balance the water last. Okay, and that's where I differ from the book, in that they start with balancing with the water. And I find that's a little too confusing, just because you never know. It's easier to start with assigning a coefficient. If you balance the water first, you're going to have to kind of guess and assume the coefficients in order to get that balanced first. So I really recommend balancing it last. And the easiest way to do that is to balance your oxygens. And that's because your hydrogens are going to show up in 2 different places. So it doesn't really matter how you do that. That's just usually the easiest way. The last step to make this a complete chemical equation is you want to determine the phase of your salt. And basically what you're determining between is aqueous versus solid. How do we determine whether or not something is aqueous or solid? Hopefully you are yelling at your computer and you're going to use your solubility rules. And remember that if it's aqueous, that's going to be soluble. And versus solid is going to be insoluble. And I mentioned it when we talked about the solubility rules, but a key thing to remember that's probably going to save you a lot of time is anything with the potassium ion, the sodium ion, or the nitrate ion. These are always soluble. And that's worth kind of putting in your memory banks, since those are pretty much your most common ions that you're going to see, especially in these neutralization equations. All right, so let's work through. We're going to do two examples. So let's look at what is the full balanced neutralization equation of hydrogen iodide and sodium hydroxide. All right. So what we're looking at is we have hydrogen iodide, right? And this is going to be aqueous because it's an acid. We're combining that with sodium hydroxide, which is our base, so it is aqueous. And we know that we're going to form water, which is a liquid, and then we have some sort of salt. Okay. Our salt, remember, is coming from our cation comes from the base. Okay. So we have Na+, and then our anion comes from the acid. So we have I-, and that's because our hydrogen out in front is going to combine with the OH from our base, okay, to form our water, which we can also, it might help you to think of it this way, HOH, okay, the hydrogen combining with the hydroxide ion. So to form our salt here, we want to know how these two are going to combine. Sodium is a +1. It's in group 1A. It's going to lose 1 electron, making it a +1. Iodine's in group 7A. It's a halogen, so it's going to gain 1 electron, making it a negative charge. When these two combine, we just need a 1-to-1 ratio. So we have NaI. Now to balance, okay, again we want to put a 1 out in front of our salt. So we have a 1 out in front of the sodium iodide. Then you want to balance your base and your acid. So we have 1 sodium ion, which means we need a 1 out in front of our base. We have 1 iodide, so we need a 1 out in front of hydrogen iodide. Now we can balance our waters, okay, which I suggest balancing your oxygens. We have 1 oxygen, which means we need 1 water. and our hydrogens should come out in the wash, and that we have 1 and 2, and we have 2 hydrogens there. Last step was to figure out our phase on sodium iodide, whether or not it's soluble or insoluble. It has sodium there. Everything with sodium is soluble, which means it is in the aqueous phase. Let's work one more example, maybe not quite so simple. We'll give ourselves a little bit of a challenge here. Let's look at the complete balanced chemical equation of the neutralization between sulfuric acid and potassium hydroxide. All right, so we have H2SO4, that's sulfuric acid. We know it's an acid, so it's aqueous. We are going to combine that with potassium hydroxide, which is also aqueous because it's our base. And we know we're going to form water, which is our liquid. And now we need to determine our salt. So remember, our hydrogens out in front are acidic protons. These are going to go to contribute to water. And then our OH minus, that also is going to go to contribute to water. Okay. And a lot of you are probably saying, hey, I already see that I have 2 hydrogens here. I already have 2 there. How can this work out? Remember that you can work all of that stuff out, work all of those subscripts matching up in the end when you balance. Okay, when we're doing a chemical change, we can change those subscripts. So all that's doing is we're going to pull both of these hydrogens off, and both of these hydrogens are going to contribute to water. Okay, yes, that means we're going to need more than one of these hydroxide ions, but that is one of the last steps that we want to look at. Okay, we just want to determine our products first, and then we can balance the equation. So our cation is our potassium, okay, which is in group 1A, so it's going to lose 1 electron, so it'll be a +1. Then our anion is a polyatomic ion. It is the sulfate ion. So we have SO4, okay, and you can either have it memorized that this is a 2 negative charge, okay, or you can figure it out that you have 2 hydrogens. Each hydrogen is a +1, so you have a total of +2. You only have 1 sulfate ion, so this has to be a -2 to balance out the +2 from the 2 hydrogen ions. All right, so when these come together in order to form a neutral compound, okay, we have a +1 for potassium, a 2 negative for sulfate, means we need 2 potassiums for every 1 sulfate. Okay, we're crossing the 1, doing the cross charge. Your 1 from potassium goes down for the sulfate ion, and the 2 goes down for the potassium. So we end up with K2SO4. Now we want to balance this. Okay. So remember, we put a 1 out in front of our salt. Okay. Now we can balance our acid and our base according to the cation and the anion. I have 2 potassiums. So out in front of potassium hydroxide, I need a 2. I have 1 sulfate. So out in front of my acid, I need a 1. Then I can balance my waters according to my oxygens. So I have 2 oxygens, so I need a 2 out in front of my water. So for those of you who are skeptical of this whole ignoring that subscript to begin with, I have 4 total hydrogens. 2 of them come from potassium hydroxide, and 2 of them come from sulfuric acid. Okay, so you have to remember that you have to wait until the end to do your balancing. Okay, if we are changing the chemical compound, which is what we're doing in a chemical equation, we can and have to change the subscripts. Okay, that was why we took our potassium ion here. We needed 2 of them to balance out our sulfate ion. So when we wrote our equation, or formula here, we have a subscript of 2. Okay, we can do that, we can change that subscript because we are chemically changing that compound. All right. Last step is we want to determine the phase on our salt. Okay, we have potassium ion here. Potassium ions are always soluble. Anything that's soluble is going to be the aqueous phase. So definitely worth practicing. These neutralization reactions are just double displacement reactions. They're just a specific kind where we're adding an acid plus a base. Okay, so you will want to work through the Q and P in your book. Okay, I will not have any sapling online questions for these, so you will want to rely on your book. You'll definitely see a neutralization equation or question just like this on the exam, so you're going to want to definitely practice that.